We're looking at 2b from section 5.2. I've got the problem all written out here. So here's the function. We're asked to find the extreme values here. So we take the derivative of the function. Here's the derivative using the power rule. We get rid of that negative exponent by writing it like this. And then we set that derivative equal to 0, just like usual. To solve this, we're going to move that over to the other side. So we'll get a -2 there. And then I'll multiply both sides by x to the 1/3, so I get that, and then divide both sides by 2, divide both sides of this by 2, then I get that equation there. That's x to the 1/3 equals -1/2, but in order to get rid of that 1/3, we raise both sides to the third power, so that if I raise -1/2 to the third power, I get -1/8, so that's critical, -1/8. That's a type 1 critical number. That's the kind where the derivative is equal to 0. We also have to notice that in our derivative, we've got an x to the 1/3 in the denominator there. If I plug in 0 there, then the derivative becomes undefined. So that is also a critical number. That's the type 2 critical number. So what do we do from there? We take we set up our intervals. We go from -∞ up to the smaller critical number, -1/8. From the smaller critical to the larger one, and then from the larger one to the end of the interval, the end of the domain. We pick our test values. Each of these numbers is on their domains on the chart here. We plug these critical numbers, plug these test values into the derivative. So if you plug in -1 into this derivative here, right there, if you plug in -1 there, you'll find that it gives you 2 minus 1, which is positive. If you plug in +1, you get 2 plus 1, which is also positive. And you'll find that when you plug in -1/16 into x here, you'll find that that actually ends up being a negative value. So go ahead and verify that if you like. And so that tells us that the function is increasing, and then it's decreasing, and then it's increasing. And so finally, we know that we have a maximum value at -1/8, -1/8, which I should have right here, not -1, -1/8, right there. And when I plug in -1/8 there, I get out -1. Okay, so you can verify that. If you take this -1/8, plug it back up into the original function here, you should find that you indeed get -1 out of that thing. And so that tells us the y value. At 0, 0, we had we had a minimum value there because the function was decreasing before 0, increasing after 0. So we have a minimum there. And when you plug in 0, the critical number 0 into the original function, you get 0 out. So we've got a minimum value of 0. Okay.